All right, so natural logs. We'll review some algebra concepts first before we get into the calculus of natural logs. Just on the off chance that somebody somewhere doesn't remember everything there is to remember about natural logs, right? That's not you, but maybe someone in the row next to you maybe forgot something about natural logs. Well, chances are you don't remember what the graph looks like, and that's okay, because we're going to get some values, kind of make a table of value, and then see if that can help us remember what the graph looks like. So natural log, that's the ln thing. ln, it seems backwards, right? Natural log should be nl, but I think it was a French thing first, so it's like log natural. It's really where the ln came from. Let's do the easiest one first. It doesn't mean it's easy, it just means it's the easiest of them. Natural log of 1. Again, you're all thinking the right answer in your brain right now, but just in case someone isn't. What's the base of a natural log? E. So we don't usually write it because we don't need to write it. There's a hidden E down there, an unwritten E. And then to answer log questions, you might remember the fishhook thing or the loop-de-loop thing, what your teacher may have called it last year, years past. It means that E to something equals 1, right? If you do the loop-de-loop, E to something equals 1. Well, what's the something got to be? 0. E to the 0 is 1, because anything to the 0 is 1. So if we're making a table of values for our graph that we're working on, if we plugged in 1, our graph's going to be y equals natural log of x. If we plugged in 1, we got 0, because the natural log of 1 is 0. Next, let's do the natural log of E. So think about the base, think about the loop-de-loop. I'm not going to write it all out again. What's the natural log of E? 1, because E to the first would give me E. So if I plug in E, I get 1. Well, what's E? Anybody remember? 2.7 something, and that's good enough for us, especially for what we'll be doing, which isn't much with it. 2.7 something, and not 2.7 exactly, but graphing wise, 2.7 something is close enough. 2.7-ish, and up to 1. Okay, well, that's part of our graph. How about the natural log of a negative number? E to what would give me a negative number? It's a bit of a trick question. There's your hint. What do you think through our options here? 0 exponent turns it into 1. What's a negative exponent do to the base? Flips it over, so a negative doesn't make it negative, or a negative exponent doesn't make my answer negative. A fractional exponent is like a root, so that doesn't make it negative. There's no way to get a negative answer. So I can't take the log of negative numbers. So this whole side of the graph is not there. I can't. It's like there's a wall there almost. I can't go over there. I can't take the log of a negative number. It's almost like I drew an asymptote right there. So we could keep plugging in numbers if we wanted to get a more accurate graph, but there's the basic picture of what a natural log looks like. And some of the key values. The natural log of 1 is 0, natural log of v is 1, and you can't take the log of a negative number. That's sort of the main things you need to know concept-wise to head into the calculus part. Let's do some properties of logs. Natural log of x to the a. Do you remember what you can do with that from your Algebra 2 or pre-cal days? Put the a in front. A times natural log x. How about the natural log of x times y? Do you remember what you can do with that in pre-cal or algebra? Blank stares, hopeful looks. Pardon?
You can break it apart.
Yes. Do you remember how you can break it apart?
You add them.
You do add them. So natural log of x plus natural log of y. And then last property, natural log of x over y. You can subtract, right? It makes sense if multiplication leads to addition, then division probably leads to subtraction. In algebra and pre-cal, you did lots of problems where you use those properties. Hopefully they're in your brain somewhere, because you're going to need them today to do... actually, you don't need them today. It's just helpful today, because when we take derivatives, rather than having to take the derivative of natural log of x to the a, which might be complicated, if we move the a in front, then we're just taking the derivative of natural log. We don't know how to do that yet, but you could probably guess that it's easier to take the derivative of natural log of x compared to natural log of x to the a. Definitely we will use it here. Rather than take the derivative of natural log of xy, which would mean we would need the product rule, we can use algebra first and kind of pay the price in algebra rather than paying the price in calculus. Same thing with division. Division, so it's going to be complicated. You can pay the price in algebra with the algebra rule, or you could pay the price in calculus, which would mean the quotient rule, which we really don't want to use if we can avoid it. So knowing our algebra rules will help make life a little bit easier when we get to the calculus rules. And really the calculus rule isn't that hard. It's just, do you know all the algebra rules to make your life a little bit simpler on the calculus side of things? So, time for calculus. The derivative of the natural log of x. This is just going to be a rule. We're not going to derive it. You're not going to know where it came from. How do we get that? You just have to know that the derivative of natural log of x is 1 over x. Now, that's good news and all, but usually we're taking the natural log of something else rather than x. Otherwise, this homework would be like one problem. Here's your homework problem and you're done. We're going to take the natural log of all kinds of stuff. So let's see how we would take the derivative of the natural log of a pink triangle. You're looking at me like, what pink triangle? Where'd that come from? You don't need a pink highlighter to do this. You could just put a triangle there. Well, let's follow the pattern. It's going to be 1 over the argument. So 1 over the pink triangle. But that's not all, because we got to remember our Tootsie Roll Pop rule. We got to multiply that by the derivative of the pink triangle. So the chain rule is big again today. I mean, it's going to be big all year long, but in fact, every time we learn a new derivative rule, we don't just do it by itself. We immediately use it with chain rule and product rule and the trig rules and all the other rules. So it's not like, all right, test 2 is over, or test 3, we're done with that. I don't need that anymore. No, we still got to use chain rule. I like remembering the formula like this because the chain rule is obvious. So that's how I will remember it. Pretty much every book, though, will simplify this and write it as the derivative over the original. And that's completely okay if you want to memorize it that way. To me, I even though this may look more complicated to write it out like this, to me it makes more sense and it helps me preserve the chain rule. It's 1 over the argument times the derivative of the argument. If you remember it like this, that's fine, but I think conceptually this is easier, even though that's a little bit cleaner to write. So I leave it to you to figure out which one kind of makes more sense to you. They're obviously the same thing, but how you think about it and how you memorize it might make it easier to remember later. And so I think this way is better because it matches the original, it preserves the chain rule. But if you prefer that, that's fine. Alright, like that's it for the new stuff. It's 1 over the argument times the derivative of the argument. Lesson over, we're done. Except that we need to see some examples. So nothing new from here on out. We're just going to apply what we now know. We're just going to find a bunch of derivatives. So find the derivative if f of x equals natural log of 2x plus 1. I'm going to go a little overboard on the first example, as we often do, and say, okay, that pink triangle is 2x plus 1. And the derivative of 2x plus 1 would be 2. So the derivative of f is 1 over the pink triangle, 2x plus 1, chain rule times the derivative of the pink triangle, which is 2. And we'd probably write that as 2 over 2x plus 1. One over the argument times the derivative of the argument. After you do 3, 4, 5 of these, you're going to be jumping straight to here. You're not going to be writing anything out like this, but I wanted you to see where the pieces came from. Argument goes in the bottom, derivative goes in the top. Number 2, y equals natural log of x cubed. So dy dx. Again, I'll switch back and forth between y prime and dy dx just so that you remember that they're the same thing. Dy dx equals, I'm not going to write out everything, but maybe we'll label the pink triangle 1 over the pink triangle times the derivative of the pink triangle. 1 over the argument times the derivative of the argument. And then we would need to clean that up just a little bit. X squareds would reduce to 3 over x. Now, there's another way to work that problem, though. If we used our algebra first, like we had to pay the price in calculus, which wasn't bad, but if we notice that, wait a minute, I can do something with that 3 and move it out front and just change that to y equals 3 natural log x, then dy dx is 3 times 1 over x. Which it's the same as the other way, which makes sense, but your choice. So I can pay the price in calculus dollars, or I can pay the price in algebra dollars, but I land at the same spot. This one was pretty simple, so it didn't really matter which way we went. It's kind of easy either way. If we get into more complicated stuff, it's probably going to be better to do the algebra that you can first, and that to make your calculus a little bit easier. But you never have to. You can slog through the calculus if you want to, or if you forget. It's not really a want to. It's a you forget a rule and you end up you forget an algebra rule, and then you end up having to use the quotient rule or the product rule, something awful. Y equals natural log of x cubed, as opposed to the natural log of x cubed, right? So that's different than that last example. Here we're cubing the natural log rather than cubing the x. So they're both sort of chain rule problems, but in terms of like Tootsie Roll Pops, it's like we reversed who's the outside function and who's the inside function. So the outside function is the cube. We know how to handle cube. Even if we don't know natural log, we at least know that handling cube is 3 times the thing squared, where the thing is natural log of x. But chain rule, chain that onto the derivative of natural log of x, which is 1 over x. And as always, that's a perfectly good free response question. But usually the free response questions are more involved than just find a derivative. That's more likely to be a multiple choice question, in which case we would clean it up a little bit and make it look like that. Y equals x squared times natural log of x. So obviously natural log is involved, but what big rule do we hopefully notice that we'll need to use on this one? Product rule, because it's x squared times natural log of x. So why don't you try this one? And since it's new, I'd probably label the pieces and show my work for product rule. If you're really confident, you could do the product rule in place. So give that one a try. Oh. First times derivative of the second plus second times derivative of the first. Perfectly acceptable free response answer. Although you've seen enough calc chat and multiple choice tests to know that that's not going to be the final answer. We're going to do a little bit of algebra just to make sure you're on your toes there. And as always, the straightforward type problems are usually multiple choice questions. The free response ones are the ones that take a little bit longer. Questions on that? We feeling okay? Like again, today's lesson is just 1 over the argument times the derivative of the argument. It only gets hard when we start combining it with other rules and forgetting the other rules. So calculus is easy, algebra is hard. It's not quite true, but sometimes it seems that way. Grading your test and you do all your lovely calculus correct and then make algebra mistakes, simplifying your answers, that sort of thing. Number 5, y equals natural log of x squared minus 4, or the square root of x squared minus 4. So right now this is like a chain rule problem with 3 layers. Natural log, square root, x squared minus 4. But we can get around some of this. Because what's the square root the same thing as? The 1/2 power. And if it's a power, we can move it down front. So 1/2 natural log x squared minus 4. So that took one layer away from us. That's a little bit easier then. So dy dx, 1/2 constant, kind of just along for the ride there. So 1 over the argument times the derivative of the argument. See if you can finish that one. 1 over the argument times the derivative of the argument. 1 over the argument times the derivative of the argument. And then the 2's cancel and just kind of cleaning things up a little bit. X over x squared minus 4. And again, pay the price in algebra so you don't have to pay it in calculus. There's 2 more. Y equals natural log of the square root of x over x plus 1. Well, without any algebra help, that looks awful because it's another like triple layer chain rule problem. Natural log, square root, quotient rule. Yuck. But let's see if we can algebra our way into a much easier problem to deal with. We already saw that the square root becomes a 1/2. So I'll move that out front, like that. But then the other rule is, I could do it from here. I could do 1 over this, that would be ugly, times the derivative of that, that would be ugly. So this would be an ugly answer right now, except that instead of that, let's use algebra. Again, pay the price in algebra world before moving to calculus world, because usually it's an easier price to pay in algebra land. Now, we still got to get to calculus world and take that derivative, but man, the derivative of this stuff, that's easy. 1 over the argument times the derivative of the argument, but derivative of x is just 1, minus 1 over x plus 1. The derivative of x plus 1 is just 1, so we're done. So that's actually an easy calculus problem. It was a hard algebra problem, but an easy calculus problem. CalcChat is probably going to get a common denominator and add those. I don't want to do that. You can if you want to. If you really need to check it against CalcChat, you could. All right, one more. Y equals the natural log of the natural log of x. Well, there's no way to algebra our way around this one. There's no shortcuts for this. I'm going to go back to my pink triangle here because I think that helps me see what's going on. It is definitely a chain rule problem. Work from the outside in. First thing I hit is natural log of something. So dy dx is 1 over the something times the derivative of the something. So 1 over, but what's the something? What's the pink triangle? Natural log of x. This is a little bit weird because the triangle is, we need to show it up here. The triangle is natural log of x, which means the derivative of the triangle is 1 over x. So this nested natural log thing, 1 over the pink triangle, 1 over natural log, times the derivative of natural log, 1 over x. And then just kind of cleaning things up a little bit, 1 over x ln x. So again, today is more about, there's a new rule. 1 over the original, or 1 over the argument times the derivative. But then we mix it in with all the other rules to make sure we still are good with product and quotient and chain, trig, all the other power rules, all the other things we got to know. All right, so the assignment, and if you know all the other rules, then the assignment's not really that bad. It's just when we get confused on the old stuff that we get messed up. 5 through 8 all, 41 to 61 odd, 65, and 73 to 77 odd. The other part of your assignment today is to sign up in AP Classroom. So some of you have done it. I looked last period, there was like 13, 14 people from third period signed up. So that's a pretty good chunk of you. I'm going to put all three up here, all 3 class periods, because virtual people will be watching this later. So if you're at home watching and you're in second period, then your join code is RAZXXM, RAZXXM. If you're in third period, at you guys live, third period is R76 K3M. And if you're in fifth period, so you're watching at home and you're in the fifth period roster, you are E92 RN6. All right, most of you have a College Board account because you've got, that's previous AP classes, that's SAT, PSAT, so you probably already have an AP account. I need you to sign up for an AP to join my classroom. Soon enough we'll be doing assignments through these because they have old AP test questions. It's really easy to assign. It's not really easy for you to do them, but it's easy for me to assign. You get a grade right away, and it's just lots of good practice stuff. It's also how you will pay for and sign up for the AP test. So you need to get in there, even if you're not taking the AP test, which I hope you are because it's an AP class. But even if you're not, you still got to get signed up for this because we will do some coursework in here. And I've just waited so long until now because all the changes between virtual and in-person and the AB days and all that stuff. But we got to get going with AP Classroom. So if you haven't already, do it right now. If you're in here, you can do it right now. Grab your phone, log into your College Board account, and put in your code. All right, let me say one more thing that applies to a few of you, not very many of you. So some of you can tune me out, but don't tune me out yet. And that is doing the homework. Like you guys, you want to do, I want you to do well in here. I think you want to do well in here. But the price you have to pay to do well is to do the assignment. Usually on the day it's given. Like you can't just let them stack up and think, well, I'll just watch Mr. Wolf work an example or two tomorrow. I mean, yes, I will, and hopefully you'll learn something when I do that, but you're not going to learn it unless you're the one doing it. So my challenge or encouragement to you guys is to do it every day. Check Calc Chat. Come ask me questions the next day. That's the only way you're going to learn the stuff is by doing the stuff. Again, most of you even at home watching, you're doing it, and I appreciate that, and you're doing fine. But some of you are not doing it, and you're wondering, I'll say it even though the person might watch the video later, I won't give his or her name. I got an email that said, Mr. Wolf, I think I'm going to fail your class. I was like, yeah, I think you are. Like, then I checked the homework grades. Like, well, they're not there. Like, well, what did you think was going to happen? If you don't do the homework, how did you expect to learn it? So, again, this isn't most of you, but it is a few of you. You need to be reminded that in order to do well, you've got to do the work. And I know it's not easy, and I know it takes a while, and I know you've got other stuff going on. But if you're in an AP class and you want to do well, you got to pay the price to do it. You're all capable of it. You're in here and you can do it. It's just you got to put in the effort to go for it. Again, most of you are doing it, and I appreciate it, but a few of you needed to be reminded of that.